Hello everyone, and thanks for watching Edupedia World videos. In this last session of mole concept, we'll just discuss about conversions of one concentration unit to another concentration unit. Alright, so in questions, a lot of times say you are given molality, but what you actually need is information about molarity or mole fraction or percentage mass by mass or so on. Okay, so we must know how to convert one from another. Alright, so let's start with that. And let's derive some formulas of conversion. First, let's discuss molarity and percentage mass by mass. Okay, how do we convert molarity to percentage mass by mass and so on. Alright, let's say hypothetically, let's say you have molarity of a solution, say as Y. Let's say you have molarity of a solution as Y, okay, and you have density of that solution, rho, density of that solution in gram per liter, and what you have to calculate is, okay, and from this data what you have to calculate is percentage mass by mass. Let's call it Z. Okay, let's call it Z. So percentage mass by mass, this is what we have to calculate. Okay, we have density, this is rho. Okay, rho is used to denote density. Alright, molarity is Y. So what is Y? Molarity is, if you remember, moles of solute divided by volume of solution. Okay, for now we are only talking about two substances solution, that is the solution has one solute and one solvent, that is A and B. Okay, let's say our solute is A and solvent is B. Alright, so for now we are only talking about solute and solvent. Alright, that is two substance solutions. So say molarity Y will be moles of solute Na divided by volume of solution. Okay, volume of solution, that is V in liter. Right, density. What is density? Density is gram per liter, that is mass, total mass of solution W. Okay, it is not mass of solute or mass of solvent. You have density of solution, so what you use is mass of solution. So density of solution is mass of solution divided by volume of solution. Okay, and what we have to calculate is Z. Z is percentage mass by mass, that is Z is equal to mass of solute. Okay, solute is A divided by total mass. Again, total mass is W, not WA, WB, it is W. Okay, multiplied with 100. Okay, you understand the notations so that it will be easier for us to derive. Okay, we cannot write complete statements every time. That's why we have used so many different variables. Okay, in fact, this derivation will have lots of variables, lots of manipulation of these variables. So it might be a bit confusing, but after a while we'll see that we don't actually have to use this formula to solve the questions. Okay, but let's get through them first. So I have molarity equals to moles divided by volume. Okay, and what I have is Z is equal to WA by W into 100. What I need is, I need to calculate Z in terms of Y and rho. Right, so I have to eliminate these variables. Z is what? WA by W. Okay, so I basically have to eliminate these two. Okay, WA and W. So how do I eliminate W? It's quite simple from here. W is simply, okay, from here, from density, W is equal to rho into V. Okay, note that V here is in liter, so density must be in gram per liter. If in your question density has been given in say milligram per ml or gram per ml or kilogram per ml, so you convert it into gram per liter for this formula. Okay, because here we need volume in liter. So I have calculated mass, total mass of solution is rho into V. That means I have eliminated one variable. Okay, I have eliminated W, so I have rho into V. Okay, now I have to eliminate WA. I am not eliminating V here. Why? Because V is also present in Y. So maybe I can, I can simply equate them. So I have eliminated W. Now to eliminate WA. WA is what? Mass of solute. Okay, here I have moles of solute Na. Alright, so what is the relation between Na and Wa? Wa divided by molar mass, gram molar mass of solute is equal to Na. Okay, you remember the formula? Moles of any substance is given mass divided by gram molar mass. So moles of solute, that is moles of A, is equal to mass of A divided by molar mass of A. So here capital Ma is gram molar mass of A, that is molecular mass of solute. Okay, this might not be given in your question, but you can calculate it. If you know the name of solute, say if it is acetic acid, you can calculate its molar mass. If it is glucose, you can again calculate its molar mass. So you can always calculate Ma. Alright, all you need is the name of solute, which will be given in your question if Ma is not directly given. Alright, so I have eliminated Wa as well. Okay, Wa is equal to Na multiplied with Ma, that is given mass is equal to moles into molar mass. Okay, that is gram molecular mass. So from here what I get is Z is equal to Na multiplied with Ma divided by rho V into 100. Alright, so if we just manipulate it a bit, Z is equal to Ma into 100 divided by rho multiplied with Na by V. Okay, I simply separated this Na from numerator and V from denominator here. Why? Because Na by V is my Y. Right, Na by V is my Y. So what I get is Z is equal to 100 Ma divided by rho into Y. Alright, so this is my formula. Okay, so if I have molarity, I can calculate percentage mass, that is mass percent, or if I have mass percent, I can calculate molarity Y. Okay, remember that Ma is molar, gram molar mass of solute, and rho is density of solution, which is in gram per liter. Okay, because unless you take care of the units, this formula won't be correct. Right, this formula has been derived for certain units. Ma should be gram molar mass, that is in gram, and rho is density of solution in gram per liter. Okay, so unless you follow the unit, you will get wrong answers. So now you can simply remember this formula for conversion of molarity to mass percent and vice versa, or let's see an example without the use of formula. Okay, I have to calculate concentration in terms of mass percent of a 2 molar solution of acetic acid given its density to be 1.2 gram per ml. Alright, so I have data on molarity and density. I have to calculate mass percent. So you can directly use the formula that we just derived. We can directly use it. Alright, we have the value of Y, molarity is 2. We have Ma is what? Molar mass of solute. So we know the molecular formula of acetic acid, we can calculate Ma. Okay, and density, in the question density has been given in gram per ml. So you can simply convert milliliter to liter. Okay, and you can directly substitute that value. Okay, after conversion you can substitute the value of density and you will get your answer. Okay, so if you have remembered the formula, then you can directly use it in your question. But a better way is to simply use logic. Alright, so I have to calculate mass percent. What is the definition of mass percent? We have just used in our derivation. Mass percent is mass of solute divided by total mass of solution into 100. So if I can calculate these values, this numerator and denominator, from my data, from the data in my question, then I can directly calculate my answer. So my aim now, my goal is to calculate W and Wn. What do I have? First I have molarity of solution. So how do I interpret molarity? Okay, we have learned this. 2 molar implies 2 mole of acetic acid. Okay, acetic acid is CH3COOH. Okay, now I have told you what acetic acid is, so remember this. Acetic acid is CH3COOH. So 2 molar can be taken as 2 moles of solute in 1 liter of solution. Alright, in 1 liter of solution. This is how we interpret molarity. So I can assume these to be absolute quantities. So remember, I can assume that my moles of solute is 2 mole and my volume of solution is 1 liter. Okay, so from 2 moles of solute, how do I calculate WA? It's quite simple actually. WA and Na is moles of solute, are related by this formula. Okay, gram molar mass, that is Ma. What is the gram molar mass of acetic acid? Okay, acetic acid, what is the gram molar mass? Let's say Ma. Let's call gram molar mass, let's represent gram molar mass with Ma. So Ma of acetic acid. Okay, so I have 2 carbons, that is 24, I have 2 oxygen, that is 32, and I have 4 hydrogen, that is 4. So what do I get? Gram molar mass of acetic acid is 60 gram per mole, right? It is 60 gram per mole. Alright, so I can calculate WA. WA is equal to Na2 multiplied with 60 gram per mole. What does this come out to be? 120 gram. Okay, 2 moles multiplied with 60 gram per mole. So this will come out to be 120 gram. So I have calculated WA. Now I have to calculate W. How do I calculate W? Okay, for that you have density. Okay, you have density. So density is mass of solution divided by volume of solution. Okay, so the density that has been given to you is 1.2 gram per ml, and the volume of solution we have assumed to be 1 liter. Okay, this is in liter, this is in ml, so you have to make the unit same, otherwise your calculations will be wrong. So let's convert milliliter to liter. How do I do that? Converting milliliter to liter, okay, it's quite simple. You simply divide by 1000. Okay, milliliter is smaller unit, you simply divide by 1000. So dividing by 1000, 1.2 divided by 1 by 1000. So this gets converted to gram per liter. Let's continue it on the next page. So I have density to be 1.2 divided by 1 by 1000, that is 1.2 into 10 to the power 3 gram per liter. And this is equal to mass by volume. What I need to calculate is mass of solution, that is W is equal to rho into V, which is 1.2 into 10 to the power 3 gram per liter, and volume of solution I have assumed to be 1 liter. Okay, I have assumed that, so that moles was 2 mole of solute in 1 liter, so I have assumed solution's volume to be 1 liter. So this means mass of solution is 1.2 into 1000, that is 1200 gram. And we already know WA came out to be, okay, from the previous slide, WA came out to be 120 gram. Right, so now simply it's a matter of substitution. Percentage weight by weight is what? Mass of solute divided by mass of solution into 100. Okay, it is simply a matter of substitution. Mass of solute divided by mass of solution into 100. This comes out to be 10%. So this is our answer, and we haven't used formula here. So either you remember the formula or you use your logic. Right? Obviously this method is lengthy, but this method has the advantage that you don't have to remember formula, especially since there are numerous tens and hundreds of different concentration units actually. Okay, we have only studied 4 or 5 of them. We have studied percentage mass by mass, percentage mass by volume, percentage volume by volume, molarity, molality, mole fraction. That is all. Okay, and we'll study normality later on. But apart from that, there are numerous other units, and even among these units, if you do your permutation and combination, you will find that deriving formula between any 2 units, say percentage mass by mass and molarity, we have derived, but we haven't derived between percentage mass by volume and molarity. We haven't derived between percentage volume by volume and molarity. Okay, so you cannot remember all this formula, you will just get confused and you cannot be sure which of them is going to come in your exam. So that is why we need to understand this method that we have done here, okay, which we have used our reasoning in. Alright, let's see another conversion and how we can use it without formula. Let's study conversion of between molality and mole fraction. Molality and mole fraction. Let's see if this is difficult or easy. Say I have a solution with molality small m, okay, and I have mole fraction say of solute XA. Again my solute is A, okay. Again we are talking about solution containing only two substances, okay, because that makes for an easier derivation. You can obviously extrapolate it for 3 or 4 or 5 substances, but that will only make things more complicated. Okay, for now the questions that we are going to be solving will mostly concern with two substance solutions. So solution is solute A plus solvent B. Alright, this is what we have assumed, that it is consisting of two substances A and B. So I have mole fraction of XA and I have to calculate molality M. Basically I have to find relation between M and XA. So one thing, if I have XA, I also have XB. You have to remember that. If I have XA plus XB, sum of mole fractions is always equal to 1. So this implies XB is equal to 1 minus XA. So if I have XA, I also have XB. Okay, so I have mole fractions XA and XB. So XA is equal to Na, that is moles of A divided by total moles N, and XB is equal to moles of B divided by total moles N. If I divide the two, so XA divided by XB, what will I get? If I divide, the ratio of mole fraction is equal to ratio of individual moles. Okay, this is an important relation actually. Ratio of mole fractions is equal to ratio of individual moles. It's quite simple. Now let's see molality. Okay, we have to find relation between M and XA. So molality M. What is molality? Moles of solute Na divided by mass of solvent, that is WB, not W. Okay, only mass of solvent in kilogram. Alright, usually in chemistry we have masses in gram. So let's say if WB given to you in question is in gram, so to convert gram into kilogram, I divide denominator by 1000, that is multiplying the fraction by 1000. Dividing denominator by 1000 is same as multiplying the whole fraction by 1000. So I have converted my mass of solvent in gram to kilogram, so that I can calculate molality. Okay, so now WB, basically here I have Na, here I have Na, so I can eliminate them. Alright, I already know XA and XB, but I also have a variable NB here, and here I have a variable WB. So I have to eliminate these variables WB and NB. How do I do that? I convert WB to NB. What is WB? Mass. Okay, WB is mass of solvent. Mass of solvent will be equal to moles of solvent into molar mass of solvent, just like we did in case of molarity. You remember just a few slides back, mass of solute is equal to moles of solute into molar mass of solute. Similarly, mass of solvent will be moles of solvent multiplied with molar mass of solvent. So this multiplied with 1000. Okay, this multiplied with 1000 will give me molality. Alright, so molality multiplied with molar mass of solvent divided by 1000 is equal to Na by Nb. Here also I have Na by Nb, so I can simply equate these two fractions. I can say that 1 is basically equal to 2. Okay, I can simply say 1 is basically equal to 2. So that gives me molality multiplied with Mb, that is molar mass of solvent, divided by 1000 is equal to XA by XB, and XB is what? 1 minus XA. So this is my formula. Okay, this is my formula for relation between molality and mole fraction. Again, you see, deriving formula is quite difficult because you have lots of variables and you have to manipulate them. and as well as remembering the formula can be quite difficult and confusing. So let's solve an example for this without the use of formula. Let's see how we can do that. We have to calculate concentration in terms of mole fraction of the previous acetic acid solution. Okay, so we have the same solution given that its molality is 1.85 molar. Alright, so we have molality and we have to calculate mole fraction. So to calculate mole fraction, we know that mole fraction XA is nothing but moles of solute divided by total moles. This is our answer. If I can calculate Na and if I can calculate N. Okay, and what is N? N is simply sum of Na and Nb. That is sum of constituent moles. So Na plus Nb. So if I can calculate Na and Nb, I can very well calculate my mole fraction. Alright, so our goal now is to calculate Na and Nb from the given data. So what data do I have? All I have is molality, and obviously I have density from the previous question because we have the same solution, so we know the density. But let's see if we have to use the density. We actually won't have to. We have already solved the example. We have already done the derivation, and from derivation we know that I don't need to use density here. In fact, even if you don't know that, it doesn't matter. Let's just try and calculate Na and Nb. So I have molality. I have molality as 1.85 m. Alright, and 1.85 molar. How do I interpret this data? This 1.85 molar implies I have 1.85 mole of A. Okay, that is solute in 1 kilogram of solvent, that is P. Okay, if you remember how we interpreted molality, concentration unit molality, this is how we do that. 1.85 mole of solute in 1 kilogram of solvent. Okay, so now I have from this data, if I can make this assumption, it means I have the value of Na. Na is what? It is simply 1.85. Okay, what I need is Nb. How do I calculate Nb? Moles of solute is given mass of moles of solvent. Nb is solvent. So moles of solvent is given mass of solvent divided by gram molar mass of solvent. That is Wb divided by capital Mb. Okay, so let's see if I have mass of solvent. I have mass of solvent as 1 kilogram. 1 kilogram of B. So converting it into grams. Kilogram to gram multiply with 1000. So I have 1000 gram as mass of solvent. Do I have molar mass of solvent? Okay, Mb is molar mass of solvent. So what is solvent? I have acetic acid solution from the previous question. If you remember from the previous question, it is an aqueous solution. Aqueous solution means my solvent is water. That is B is actually water. And what is molar mass of water? Molar mass of water is 18 gram per mole. Okay, so 1000 gram divided by 18 gram per mole. So this gives me 1000 divided by 18 gram. So this will actually come out to be around 55.55 mole. Okay, this is what we have here. Moles of solvent, and I already have moles of solute. So simply I substitute those values here for Na, okay, and Nb. Okay, and I solve this fraction and get my answer of XA, and from XA I can calculate XP as 1 minus XA. Okay, so see, now this was quite simple. Okay, you cannot, believe me, you cannot remember the formula. Even if you remember it now, you will forget it 1 month later or 2 months later. You have to give your exam every year in March or April. Alright, you cannot remember it forever. And especially since this is only one chapter, you will have several chapters, and in those chapters you have other formulas that you actually have to remember. There is no other way out. So let's skip these formulas and simply try and use our reasoning and our logic to solve the question. We already know all of the concentration units, so we simply try and use their definitions to solve our question. Okay, So this finishes up our conversion part. Again, there can be a lot of different conversion formulas. Okay, there can be any type of question on conversion. You just need to remember the definition of units. Okay, once you know the definition and formula of unit, you simply try and eliminate variables one by one. Okay, you simply find the values of variables from the given data in your question, and you won't face any problem in your question. Okay, so this here now we are finishing our mole concept chapter. All right, so the next chapter that we'll be starting is atomic structure. Okay, again we'll follow 11th grade CBSE board syllabus. All right, and we'll try and cover basically a little more than that. Okay, but as far as your CBSE board syllabus is concerned, you won't have to refer any other book or theory material from anywhere, as long as you follow all of the lectures in the order I teach. Okay, so good luck and until next time, and once again thanks for watching Edupedia World videos. Okay.